Hello, my favorite pre-cal class. This is Miss Letchworth again. Happy New Year! I was really hoping to be at school today, but my mother is 80 years old and she's sick and she's in the hospital and she needs me right now. So I am spending my first day of the new year making this nice little recording for you so that you will have all this lovely pre-cal honors knowledge that you need to do well on your state test and to do well when you take calculus. Teaching a subject that I just love. This is one of my favorite things, and I know I say that all the time, but it's true. It is. This is limits. We're going to, it's an introduction to limits. I'm going to show you what we refer to as the graphical and the numerical method today. Along with what we refer to as continuity, how you can look at a graph and tell whether a graph is continuous or not, and how you can also use a limit to tell if it's continuous or not. I do have a handout for you that the sub should give you, so follow along with the handout. The first couple of things I didn't write up here. So look at your handout. The first thing describes what we refer to as points of discontinuity. And points of discontinuity, they occur when you have to lift your pencil when tracing a graph. So if you're tracing a graph and suddenly you have to pick your pencil up, put it back down, then that means it's discontinuous, okay? And in number 2, it tells you at what kind of points that's going to happen. And these are things you should be familiar with. We talked about them early on in the semester. But they're going to happen at vertical asymptotes, which are non-removable, which is non-removable discontinuity, vertical jumps, which is also non-removable, and a hole, which is called removable. The third thing that is on your handout is this theorem right here. This is how you can tell if you have a point of discontinuity or not. But if the limit, LIM means limit, if the limit of f of x as x approaches a is equal to f of a, then f of x is continuous at x equals a. And I'm going to explain that a little bit more later on in this lesson, okay? So don't freak out over that yet. All right? If you look at number 4 on your handout, when we talk about a limit, then what we're doing is we are referring to the y value that the function approaches as x approaches a certain x value. We actually use limits to describe horizontal and vertical asymptotes early on in the semester, and what we refer to as end behavior. All right? So we're going to talk about different kinds of limits this time. All right. Number 5, if the limit of f of x as x approaches a from the left, that superscript of a negative means you're approaching a from the left side of the graph. If that is equal to the limit of f of x as x approaches a from the right, the superscript of plus means you're approaching a from the right side of your graph, then the limit at x equals a actually exists. What that means is that your limit will actually be some kind of number. You will get a number for it, okay? Now, if these things are not equal, then that means that the limit does not exist, and we write DNE for that, okay? Look at number 6 on your handout, and it's reminding you to think of a limit as a journey, not a destination. So think of it as something that, as the value that y is approaching, but it may not necessarily get there, okay? May not arrive at it, all right? So think of the y value, you know, when you're looking at the y value that the function approaches as x approaches a certain value a, then you want to know what is it approaching, not what will it get to. That's very important, okay? Now, none of that really makes sense yet, but I'm going to repeat myself, all right, a lot as I go through some examples. And we're going to start with number 7 on your handout. this is an example of a continuous function. And what I mean by that is if I put my pencil on this function right here and I trace the function, then it's a smooth continuous curve. It's going to keep on going. I never have to pick my pencil up. What that means is I'm not running into an asymptote, a jump, or a hole. Okay? So this is continuous. It's continuous at this point right here, x equals a. And by the way, when we talk about continuity, we are generally looking at a particular point, just one point. And in this case, we're looking right here where x is equal to a. We want to look at that point. So this function is continuous at that point. And for right now, what we're going to do, we don't really care if it's not continuous at any other point. Okay? All right, so got some fill in the blank things to do on number 7 here. First of all, it's asking you what f of a is. Well, you've seen that for a long time, ever since Math 1. What that means is if you go to your graph where x is equal to a, then what you want to know is what is the corresponding y value. Well, this ordered pair right here, the x value is a, the y value is b. So at this ordered pair, this is telling me that f of a is equal to b, whatever those are, okay, whatever numbers those would be. All right, the next notation you see on number 7 is the limit as x approaches a from the left for f of x. Okay, what that means is if I'm over here on the left side of a, okay, and you can actually imagine a vertical line right there. Just keep in mind that that vertical line is not an asymptote, but you can just kind of imagine that it's there separating the left side of the graph from the right side of the graph over here. Okay, but as you're on the left side of A, that's what that little superscript of a negative means. Means you're on the left side of A, and as you're coming along and you're trying to get where x is a, so I'm going to trace this graph until I start approaching where x is equal to a. Well, as I approach where x is equal to a, I'm going to ask myself, well, what y value is what y value is f of x approaching? And f of x is approaching b. Okay, and again, don't think of it as it's going to necessarily get there or not. Just think of what is it approaching. All right. So from the left side of A, as we approach where x equals a, you're asking yourself, well, what is y approaching? Y is approaching b. All right. Now, your next question up there, your next fill in the blank is, what about your limit from the right side of A? That's what this notation means. It means as you approach x equals a from the right side, what is f of x, or what is your y value approaching? So I'm going to do the same thing, except I'm going to start on the right side of a now. I'm going to come over here, and I'm going to ask myself, well, as I trace this graph, and as I get closer and closer to where x is equal to a, I want to know, what is y getting closer to? Well, y is getting closer to b again, right? Okay? Well, look at this. Your limit from the left side is the same as your limit from the right side. Okay? That's what number 5 was all about. If your limit from the left is equal or the same as your limit from the right, then the limit at x of a exists, and that limit will be a number. And the way that we write that is your next fill in the blank. We say that the limit as x approaches a of f of x is equal to b. And that's because the limit from the left is equal to b, and the limit from the right is also equal to b. Therefore, your limit as x approaches a is also equal to b. Okay? Let me see, that was your only fill in the blank. But what I want to do with this graph right here, remember I told you that this graph was continuous where x is equal to a, because as we traced it, when we got to where x is a, we did not have to pick up our pencil. Well, that goes to what number 3 was talking about. If your limit as x approaches a of f of x is equal to f of a, then that means that it's continuous at that point at x equals a. Well, look right here. The limit as x approached a and f of a, they're both equal to the same thing. Therefore, what I can say is that f of x is continuous at x equals a. And that's because of theorem number 3. Okay? All right, now let's look at some other scenarios here. Let's look at number 8. This is a case where we have a whole where x is equal to a. And we're going to go through the same thing, same steps that we just went through. We're going to say, well, what is f of a? Well, f of a, there's a whole there. And what that means is that when x equals a, there is no corresponding y value. So it's undefined. We don't have a y value there because there's a hole right there. Okay? All right. Well, let's see about the limit. Keep in mind now, a limit is a journey. It is not a destination. A limit is what is your y value approaching, not necessarily what is your y value going to actually get to. So you got to be careful here, okay? So again, I'm going to come on the left side of A, and I'm going to trace this graph. As A keeps getting closer, as X keeps getting closer to A, what is Y getting closer to? Well, it's getting closer to B. It's not going to get there because there's nothing there where Y is equal to B, but it is going to approach it. So the answer here is B. Now let's do the right side. Remember, what are you approaching? Okay? Not what are you actually going to get to. Just what are you approaching. Alright? So from the right, here we go again. We're going to approach where x is A. And ask yourself, well, what is y approaching? Well, it's approaching B. It's not going to get there because there's nothing there. But it is approaching B. Okay? So what you see is that your limit from the left is equal to your limit from the right. Therefore, your limit does exist. Okay? So really, if you're not quite getting what I'm saying here, always remember this. Limits exist at holes. A lot of students think they don't, but they do. Okay? Limits will exist at a hole in your graph. Okay? All right. Now, is f of x continuous at A? Well, your limit as x approaches A is B, but f of A is undefined. Remember, if this number right here is not the same as this right here, then f of x is not continuous at that point. It can be continuous at other points, but not at that point. Okay? All right, let's look at number 9. Here we have a vertical jump. Let's go through the same thing. Okay? Well, what is f of A? Well, according to this, I have an asymptote. What that means is there is no y value for A once again, so that is undefined. That's because you have an asymptote there. All right, well, let's check out this limit as x approaches A from the left. Okay, so start over here on the left side of A. As x approaches A, y keeps going up, 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 up forever. It's approaching positive infinity. Well, that's not a number. That should tell you something right there. What about from the right side? Okay, let's come over here to your graph on the right side. As x approaches A, y keeps going down, 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 forever. Negative infinity. Okay? All right? Infinity and negative infinity, they describe in behavior. They don't tell you what a limit is. Okay? So your limit here does not exist. Okay? Definitely f of a and the limit at a are not the same. Therefore, f of x is not continuous at x equals a. Okay? All right, number 10. Okay, here we have a vertical jump. Let's go through our steps again. F of a. Okay, f of a, that we actually have a point right there where x is a. So that ordered pair right there is AB. So f of a is equal to b. Let's check out the limit as x approaches a from the left. So we start at the left. As x approaches a from the left, y gets closer and closer to b. Let's do the right. The limit as x approaches a from the right. As we approach x equals a from the right, y is approaching c. Well, these numbers are not the same. Remember, your limit from the left must equal your limit from the right. They don't. Therefore, your limit does not exist at a. Okay? And because your limit does not exist at a and f of a equals b, these two things are different right here. That means that f of x is not continuous. At x equals a. Okay? All right, now, here we go, number 11. This is the numerical method that I'm about to show you. Okay, what I was just showing you a while ago is your graphical method. This is your numerical method. Your numerical method means to make a table. That is written on your handout, okay? But anytime you're asked to find a limit numerically, then you are going to be making a table. And what you do is this wants to know, well, what is your limit for this function, 3x plus 1, as x approaches 2? So what I do is I put 2 right in the middle of my table. I pick values on the left side of 2 that are really, really close to 2, like 1.9. I'm talking really close. So I can get even closer with like 1.99, can I? And even closer with 1.999, okay? And then I also put values on the right side that are really close to 2, okay? Like 2.1, that number's on the right side of 2. But I can get closer to 2 with a 2.01. So I'm talking, I want to be really, really close, okay? So what about 2.001? Okay, so you want to pick values that are really, really close. And what I usually do, okay, just to show you how to set this table up, I put the a value, so to speak, x approaches a, whatever that is, I put that right there. In this case, it's 2. And on this end, I put 1/10 on the left side. So if you do 2 minus, oh, how can I do this? Oh, I'm sorry, this is looking ugly. If you do 2 minus 1/10, okay, you get 1.9, okay? And then I just do 1.99, 1.999, okay? And then to get this number right here, just do 2 plus 1/10. And then to get closer, just keep putting a 0 between the decimal point and the 1, and that keeps getting you closer. Okay, so that's how you set your table up. Now, to get the y values, oh, I let my calculator do all this. Yes, I do. Okay, all you have to do is, on your calculator, okay, is go into y equals. If you have any plots turned on, make sure you turn off all plots. It's just going to mess you up, okay? But go into y equals, and in y1, I'm going to put 3x plus 1. And then I'm going to press second table set. Press second and then table set. Okay. And put your independent variable. You have two choices, auto or ask. Make sure ask is highlighted. Okay. Keep your dependent variable on auto. Okay. And then everything else, it really doesn't make a difference. Okay. It's just these two things. You want independent on ask and dependent on auto. All right. And then press second table. Sorry, you guys, I had a cold or something the whole Christmas break. Okay, and if you have any values in there, just press delete to get them all out. Sorry, I'm doing it on my calculator. Okay, and then underneath where it has X, just put these values. You might run out of space. I don't know. Let me do mine. You'll put 1.9, 1.99, 1.999, 2, now I think you might have room to put them all. 2.001, 2.01, and 2.1. Yep. Okay. In that X column. And as you're putting all your numbers in that X column, you're going to see that Y1 column start to populate. Okay? And the numbers that I got were 6.7, 6.97, 6.997, 7, 7.003, 7.03, and 7.3. Okay? All right, so these are your numbers that you've got. Now, what you want to do now is remember these numbers are on the left side of 2. So ask yourself, okay, here's your X. As X approaches 2 from the left, let me do that in a different color, just for kicks. As X approaches 2 from the left, what is Y approaching? It's approaching 7. So your limit as X approaches 2 from the left of 3x plus 1 is equal to 7. Then ask yourself the same question over here. As X approaches 2 from the right, what is Y approaching? It's also approaching 7, isn't it? Okay, so what that means is the limit as X approaches 2 of 3x plus 1 is equal to 7. Okay, because if your limit from the left is the same as your limit from the right, then your limit exists. Okay, all right, let's try number 12. We'll do the same thing. Okay, put this into Y1. All right, either use function 1 so that you can get it set up as a fraction, or when you put it into Y1, make sure that you put parentheses around your numerator and then your division bar and parentheses around your denominator. Okay? I am putting mine in the calculator right now, so hopefully you are too. Okay. All right. So we're going to put 16 right in the middle. 16 minus a tenth is 15.9, right? Let's get closer. Let's get closer. Okay. Add a tenth to 16, that's 16.1. Let's get closer. Let's get even closer. Okay. All right. Go to your table, just like I showed you. You just set up your table. When you went to second table, set, you put independent on ask, independent on, ask and dependent on auto. So you're good. You don't have to do that again. Just go to your second table and delete all those values that were there and put these new ones in. 15.9, 15.99, 15.999, 16, 16.001, 16.01, and 16.1. Okay, and woo, I'm getting some big crazy numbers here. 7.9875. 7.9875. 7.9987. 7.9999, something like that. Error. Wonder what that might mean. 8.0001, 8.0012, 8.0125. And here we go. Here are our questions. Ready? As x approaches 16 from the left, what is y approaching? I would say it's safe to say that the limit as x approaches 16 from the left of all that, yes, you have to write all that, is equal to 8. Come over here. As x approaches 16 from the right, what is y approaching? I would say it's safe enough to say 8. The limit as x approaches 16 from the right of all that is 8. Okay? Your limit from the left is equal to your limit from the right. Therefore, your limit is 8. The biggest mistake I see here is students will tell me, because they got an error right here, is that it does not exist. And that is not true. What this means is your limit as x approaches 16 of this function, okay, does not equal f of 16. That's what that means, okay? Because if you were to put 16 right here into your function, 16 minus 16 gives you 0 on top, and then the square root of 16 is 4. 4 minus 4 gives you 0 on the bottom. That's what we call indeterminate form. We'll talk more about that when we get to calculus, okay? But essentially what it means is you have some discontinuity right there, okay? Because your limit as x approaches 16 does not equal to f of 16. So what this is telling us is that f of x is not continuous at x equals 16. Okay, let's look at 13 and let's do the same thing. Let's see what's going on here. This time we are approaching 0, so 0 right here in the middle. On the left side of 0, what are we going to have here? Maybe a negative 0.1. I'm actually having to think backwards here. Yep, a negative 0.1. Okay, to get us closer, I know this is funny, I have to think about my number line when I do that, okay? Negative 0.1 gets us really close to 0, right? So I would say a negative 0.01, negative 0.001, oh, this is ugly. Okay, same thing over here, but it's going to be positive 0.1, but a positive 0.01 gets us closer, and 0.001 gets us even closer. All right, so let's put that in the calculator. It's a trig function, Make sure with trig functions that your mode is in radians. For trig functions. And again, since it's a fraction, make sure you're going to put parentheses around all of that, then your division bar, and then parentheses around that when you put it into y equals, okay? So parentheses sine 3x divided by parentheses 3x. Go to second table. Delete out all those values from the last problem. Let's put these in. Negative 0.1, negative 0.01, negative 0.001, 0, 0.001, 0.01, and 0.1. Okay? And these are the values that I get. 9.8507. I'm sorry, that is not a 0.9, that is a 0.9. My bad. Hold up. Wait a minute. Oh, that's a highlighter. I don't want a highlighter. There we go. Alright, 0.99985. One error. Be careful. 1.99985 and 0.98507. Okay? Alright, here we go. From the left, y is approaching 1. From the right, y is approaching 1. My bad. Let me put that little negative right there. So your limit as x approaches 0 of f of x is equal to 1. This is actually a limit you're going to learn to memorize. Okay? There's a whole list of them in number 14 on the back when we get there. Okay? Alright, remember, so your limit is 1 because the limit from the left is the same as the limit from the right, and it's that number. Just because it says error there doesn't mean the limit does not exist, okay? The only way the limit would not exist is if this number, whoa, Nellie, what happened right there? Here we go. Is if this number is different from that number. If these are different, then that's when right here you would write does not exist. But since they're not different, the limit does exist, and it is that number. It is 1. Okay? Now, if you flip on the back of your handout, you have a list of limits that you need to memorize, and I could explain them better in person. So until I'm in class in person, just memorize them for now. Okay? All right? And let's jump over to number 15. Okay? So we have this graph right here, and what I would like for you to do for number 15, and I'm going to trust you to do this because you're so awesome, yes you are, is try all those problems yourself first. It's asking you what f of 1 is, and then it's asking you, you know, what is your limit as you approach 1 from the right, and then what is your limit as you approach 1 from the left, and so on. There's a bunch of problems down there, okay? It's asking you to find all of those things, and what I would like for you to do on your own, okay, is try them, okay? Just try to figure out what the answers are yourself, okay? Pause the video, try to answer everything, and then play the video back, and I'll have your answers up here for you. Alright, so here are your answers. How did you do? Okay, I'll leave these up here for a little while, for a few seconds. Of course, you can pause it to check it. Alright, and let me move these over so you can see them better. And then you can pause the video again at some point to check them. Okay, I know you made 100, no doubt about it. Since you made 100 on 15, try number 16, why don't you? Let's do this again, okay? Let's go to number 16. And I want you to do the same thing. I want you to try all the problems that are listed on your handout, and then start the video back and check your answers. Alright, so here are your answers. See how you did. Check them out. Okay, there you go. I'll leave that up there for a few seconds. You can put it on pause and check it. And let me move it over here so you can get these as well. Alright, so I know, as a matter of fact, that you just get this 100. You made 100, didn't you? Yes, you did. Okay. Hey, if you have any questions, send me a remind, send me an email, do something. Okay. Message me on Edmodo, do something, but don't sit there not knowing how to do this stuff. Okay. It's too important. Alright. And I hope to see you later on this week at some point. Alright. Your assignment will be in Edmodo. Okay, hey, I miss you guys.